All right. Welcome to the second of our regular webinars on FSLogix. My name is Aaron, and today I'm going to talk about FSLogix app masking and Java version control. Just a quick look at the agenda here. This should be a fairly short and sharp webinar. Do a recap of what I talked about in last month's episode. And we'll then talk about FSLogix app masking and Java version control and how they assist in delivering applications in both virtual and physical desktop environments. And finally, just a quick wrap up on next steps if you're looking at evaluations or how to deploy this in your environment. So just a quick recap on last month's episode, I introduced you to Hambic, who was had some requirements, I guess you could call it, to deliver a great end user experience in his virtual desktop environments. His boss, I guess, Steve, is very much behind what Hambic does and very eager to take up new technologies, but is also fairly demanding in the type of end user experience he wants. So Steve was expecting the same type of end user experience in a virtual desktop environment as he gets on his local PC running Windows 10. And Hambic was able to deliver that with Profile Container and Office 365 Container. So the key piece there being, from the administrator point of view, is simplifying what it takes to administer and operate a virtual desktop environment for the end user environment, whether that's the actual profile or it's Office 365 applications. Basically, ease of use for the administrator, and for the end user, it's about delivering the same user experience as they expect from a local PC. This month's episode is going to be a little bit different, so we'll talk more about applications. So to do that, I want to introduce you to Matt. So Matt, a little bit like Hambic, I guess, he works in an organization where he is having to manage applications for virtual desktops, but as well as physical desktops. Certainly in virtual desktop environment, he comes with his own challenges, but he has a wide array of applications and devices that he needs to manage applications for. So in his virtual desktop environment, he has, I guess, some specific operational challenges. He needs to manage multiple desktop images. He has a wide array of applications to manage and deliver to, again, a wide array of end users. So they have different application needs, and because of that, he has a set of applications that may or may not operate nicely together, or he has some specific operational or licensing challenges around those applications. So whether that be an application or whether it be something like an Office add-in or even printers and fonts and so on, he's having to create multiple desktop images to deliver those sets of applications. So some of those challenges include, as I said, applications that may or may not play nicely together in the same image. He may have applications in that image that once they log on, because it's a virtual desktop image, that user has access to all of those applications. And even if he was to use traditional tools such as Microsoft App Locker, for example, all he's doing is just removing access to that application. The user can still see all of the entry points into that app. Additionally, he has some application licensing challenges. So he has applications, for example, Adobe Reader and Adobe Acrobat in the same image, and he needs to ensure that because those applications only licensed, or Acrobat in this example is only licensed for a specific set of users, he needs to make sure that only those users can get access to Acrobat. He wants to do it in such a way that if you don't have access to Acrobat, you don't see it. Another great example that he has is Microsoft Visio and Project. So everyone who gets access to these desktops has access to all the core applications in Microsoft Office, but some users need access to Project and Visio. And again, it's he's moved to Office 365, but it's a per user based license for these applications. But he wants to do it in such a way that if the user doesn't have access to Project or Visio, they don't see it. He doesn't have to go dig deep into and do some hardcore customization, I guess you could call it, around that image to ensure that when a user logs on, they don't need that application, they don't actually see it or don't have access to it. Whether that be shortcuts, file type associations, or integration between other applications. So he has application licensing challenges, and also because he's running an enterprise, it has some legacy applications built around Java. He has multiple applications of the Java runtime that he needs to juggle. So he has some challenges that aren't necessarily unique in every environment, but certainly challenges that provides a certain level of operational overhead on top of that desktop environment that he could certainly do better. So Matt and Hambic are good buddies. Hambic, of course, is fully aware of what FSLogix can do, and he's got experience in that area, so he's been able to step in and help Matt solve these particular challenges that he has. So he's introduced him, of course, to FSLogix, and what we're here to talk about today is the app masking and the Java version control, which can assist with Matt's specific challenges. So first up with app masking. I think one of the great things that FSLogix does is the simplicity in the approach to the product. So in last month's webinar, I talked a little bit about the architecture, and the architecture was the FSLogix agent. In this case, it was Profile Container and Office 365 containers, so management was done through group policy, and the containers live on a file share somewhere. So very simple to deploy, very simple to manage, and not introducing a very high level of complexity to solve those challenges around the end user environment. Same is the case for applications. So the app masking feature is part of the FSLogix agent. So for Matt to solve his challenges, all he's having to do is deploy the FSLogix agent into his virtual desktop environment, and maybe in there he's also using Profile Container and Office 365 containers, so it's one agent to do the lot. And again, if he's doing a lot of these application management challenges or solving his challenges on physical desktop environments, again, it's exactly the same agent that he's deployed to those. So app masking does a few things, and it's fair to say that in the past we would have used tools such as Microsoft AppV, and there's some other ones as well to maybe solve these challenges, but they introduce their own level of complexity. So what app masking does do lots of those things in a much simpler approach. So with application masking, we can put all of these applications into the image, whether it's an image I'm delivering, virtual desktop images I'm delivering via XenApp or XenDesktop, maybe it's Microsoft RDS, maybe it's even VMware Horizon. Again, it's also independent of the operating, I guess, the hypervisor underneath and the platform that it's on. So app masking supports Windows, of course, but I could be deploying those environments on any on-prem hypervisor or public cloud, Azure, AWS, those types of things. And what we can do for virtual desktop environments is we can put all of those applications into the image. So immediately what we've done there is reduce the number of images that Matt has to manage. Then what we can do is we can create application definitions. So a definition of application is where that application lives in the file system, where that application lives in the registry. And as I said earlier, that application could be, it could be a desktop application. It could be a Microsoft add-in, Microsoft Office add-in. It could be the JRE, for example. It could be fonts. It could be printers and so on. So if you consider something like Adobe Acrobat, which is made up of a number of components that include the application, includes a printer and so on, I can go ahead and create a definition for that application, hide that application from users who don't have access to the application, and I'll show you this in a demo in a second. So we have different ways to control access to the application. It could be something as basic as user group. And so that'll fit in with user-based licensing for their application. Or we could have scenarios where, advanced scenarios perhaps where, depending on where the user actually is, I only want to give access to that application if they're sitting inside my corporate network. Or if it's, I'm solving per device-based licensing challenges, I can say, especially in a virtual desktop environment where the application isn't executing on the device where the user is actually sitting in front of, I can say when you're on this thin client or this PC that you're getting a remote session from, that's when you get access to the application. So let's take a quick look at how this works. So I have in my environment here, I have a couple of desktops. Just give me 2 seconds, I think. There we go. Hopefully you can see my screen now. I have a couple of desktops, right? I've got a XenApp environment that I'm delivering via Windows Server 2016, and I have user 1 here with the blue background. I've got a number of applications in the image. I've got user 2 with the green background, and he has access to the same set of applications. From an administrator point of view, what we have in this image is a whole set of applications. So I've got a single Windows Server 2016 image that has the XenApp VDA and a whole set of applications in it. And now I'm delivering that image to multiple users. You can see here I've got things like Firefox, Paint.net, I've got Office in there, Skype, and so on. Things like maybe FileZilla. I've got some Java applications and Microsoft OneDrive and so on. So with FSLogix app masking, I can go and define a set of applications and control access to those apps. So if I define a Chrome application, for example, I can define where that application sits in the file system, where it sits in the registry. I can do the same thing for Firefox and Paint.net and so on. So you can see over here in the image, I've got VLC Media Player, and what I want to do is restrict access to that application, depending on, or only provide access to that application depending on who the user is. So I need to define a definition for that application. So this is as simple as creating a new definition. I'll call this VLC Player. And I can choose from the list of installed applications. So you can see here that I've created an image, I've installed all my applications, I have the app masking rule editor that as the administrator, I've installed in my image as well. And I can go and pick from my add remove programs to define this application. So it has a program installation directory. I click scan, and the editor will go and create that application definition for me. So you can see here I've got the file system, registry, and locations and so on, and I could even add additional locations. So what I will add in here is, go to File, let's have a look at the shortcut that's on the desktop there, the VLC Media Player on the desktop. So if we go have a look at this, go to Desktop, there's my shortcut, and I've defined an additional, manually defined an additional component inside that application. Now I can define different rule sets that allow access or deny access to that application depending on what I want to do. So the default here is for everyone says no. What that means is if I don't add any rule sets and I deploy this rule set to the target machine, no one will actually see that application, but I don't really want to do that. What I want to do is say I want to deny access to everyone except if you are in a particular group. So I have a group here called VLC Player. And I can say, actually for everyone, I say the rule set does apply to everyone. And I go back to VLC Player and I can say the rule set does not apply. So what that means is for everyone, that application will be hidden. For if you're in the VLC Player group, the application will not be hidden. And then maybe I've got different scenarios there. So I can grant or deny access to the application if a specific process is running, if I'm in a particular network location, maybe it's on a particular site, inside or outside the network, particular computers or machines that are in an OU, or even if a specific environment variable exists on that endpoint. So I can click OK here, and if I go look on the file system, I can see my definition here. Obviously, I've spelled player incorrectly, but you get the idea that I've gone and created a definition. I've created rule assignments for that application, and I can go and deploy it. Now, coming back to the way FSLogix works with the simplicity of the, I guess, the administration point of view or the architecture of the product, is the product is only implementing the agent. With containers, the configuration is done through group policy. With app masking and Java version control, the configuration is done through these FSLogix rule files or definition files. And I would copy these to the endpoint, whether that's my virtual desktop or my physical desktop, using my existing tool sets. The idea is not to go and introduce any additional tool sets or replace any tool sets that you're already using. So if it's a virtual desktop environment, for example, I could put those rule sets into my master image and deploy it out. If it's persistent virtual desktops or even physical PCs, and maybe I'm managing those through something like Configuration Manager or some third-party enterprise software tool, I could use Configuration Manager to deploy those rule sets. I could even use something as simple as group policy to copy them around with a computer startup script, or even just a PowerShell script that will go and copy those rule sets around for me. So what is pretty cool about this is when I go and apply these rules, I'm going to copy these into the target directory where they're supposed to sit for the agent. What the agent will do is it watches this directory and then applies those rules as soon as it sees changes. So when I go and copy these in, if you notice here back in my user sessions, I can see all these shortcuts on the desktop. My blue user here has got Firefox, Chrome, Paint.net, VLC Media Player. And the same thing with the green user, has all these access to these applications. So user 1 has access to a certain set of applications. User 2 has access to potentially a different set of applications. So I'm going to go back to my administrator session here, copy these in, simulating what might happen if I'm copying those around with a specific tool, whatever that might be. And I can see in real time on these sessions that those applications have disappeared. So my blue user has access to Chrome now and no longer has access to Firefox. And vice versa with my green user. No longer has Chrome, but does have access to Firefox. So for all intents and purposes, those applications do not exist in the file system or in the registry. If it's something like Visio Project or Acrobat or something like that, for example, consider additional entry points. If I take a Word document, I can go and insert object, and I can choose Visio and insert a Visio diagram inside a Word document. Because now I have completely hidden that application from that user, they cannot see it at all. There's no shortcuts, there's no file type associations. For all intents and purposes, it doesn't exist in the file system, and it also won't exist in those extra applications that might have these, these little entry points in there that I can't take care of unless I go and hack the registry. Now what we've done is that we've done a very simple approach to define what an application is, define how you get access to the application under different scenarios, maybe who that user is, and I'm applying those in real time. Very straightforward. So that's app masking. I think some of the great things about app masking is that you can certainly use it in scenarios to replace the challenges that we might have been using alternate products like Microsoft AppV to solve. AppV, for example, is great at application-to-application compatibility issues. Maybe there's always scenarios where I need some form of isolation. That's what AppV is great at. What it does, though, I think, is it introduces a certain level of administrative overhead and complexity that we are able to solve with FSLogix app masking. So we actually have customers who have removed the need to leverage Microsoft AppV completely, and they're using FSLogix app masking instead. I keep with the existing methods of deploying my applications. I define what my applications look like, deploy my rule sets to my target desktops very simply. And additionally, I can even use it with third-party products. Citrix has application layering, for example. Excellent tool if you're using XenApp and XenDesktop tool sets that is likely available to you. But I can use app masking in conjunction with Citrix app layering, for example. Adobe Reader and Acrobat is a great example of this. I can put Adobe Acrobat and Reader into the same layer. I can patch them the same way because these two applications basically expect to be installed next to each other. But then I can create application definitions with app masking to control who has access to those applications in that layer. So that's app masking. Let's have a quick look at Java redirection, and this is exactly what it sounds like. In this instance, Matt has a number of traditional or legacy line of business applications based on multiple versions of the JRE. Some of these applications he's not going to be able to get rid of in the short term. Potentially they haven't been updated by the vendor in some time, and they have been written and targeted to a very specific version of the JRE. They will not run in the latest version, or perhaps they don't even run in some older versions. So for particular applications, he's stuck with that specific version of the JRE. That application may be a website, a web application, or it may be even a local Java application. Either way, we can define our target application and define the version of the JRE that we want that application to use. So when that application starts, it will leverage the version of the JRE that it actually expects. Additionally, what we can do is we can now integrate this with app masking. So the JRE is just another Windows application. It has entries on the file system, entries in the registry, so we can create a definition for that application. And if I have a set of users who don't need access to Java, for example, or don't need access to those applications based on Java, they don't need to see the JRE. And traditionally, the JRE has been an application that you have to stay on top of updates because there are a certain set of vulnerabilities in that application. So if I can get to a scenario where perhaps that application is only needed, or the JRE is only needed when it's running, or if I don't need access to that application, I don't need to see the JRE, or maybe I stick with the latest JRE in the build, but I also have the older JRE for those specific applications, I can leverage FSLogix app masking to define those versions of the JRE and restrict access to them depending on different scenarios. If you don't need access to it, you don't need to see it. So the Java redirection then in action is pretty simple. I go and define, again, I have a rule set. I define what my application is. Is it a URL or is it an application? If it's a URL, I can define the URL in there, and it supports wildcards and so on. So I might have a specific URL with different applications below it, but typically it's going to be the high-level URL, and then I can point it at a specific version of the JRE. And then if it's an executable, of course, then I can do the same thing. So in this scenario here, I have a number of applications. Very basic, of course, I can see that I've got a Java tester, another site that is whatismybrowser.com, and when I navigate to either of those websites, I'm going to get the right version of the JRE. And then the last one is an actual application. An executable that is running locally needs the 1.7.0 to 65 specific version of the JRE. So in practice then, it just looks like this, exactly as you would expect. I open the browser. Largely today, modern browsers, I guess, have dropped support for JRE, so you're typically going to be seeing this in enterprise environments, still on Internet Explorer. But here we go, I've gone to java.com, and I in my image, I have the very latest version of the JRE, and therefore when I go to basically any website that I haven't defined, I'm going to see the latest version of the JRE loaded. If I go to my specific version here, as I can see right in the middle in the pink box, I can see that it's actually loading the 1.7 version of the JRE. So it works within the same browser window, seamless to the user, whether it's in a browser or whether it's an application locally. And it just gets the version of the JRE that I expect. So that's about it. Very, very simple, short and sharp, as I said. That is I'll start again. That is FSLogix app masking in a nutshell, and FSLogix Java redirection. App masking, as I say, is great for defining or solving a number of challenges, whether that be reducing images in our virtual desktop environments, or solving application licensing challenges, or just reducing the complexity in those environments. If a user doesn't need to have access to an application, let's just make sure that they don't see it. App masking is equally applicable in virtual and physical desktop environments. Typically, we're seeing things like solving licensing challenges in virtual desktop environments, which you may not necessarily have in physical desktop environments. But things around maybe juggling versions of the JRE and controlling access to those, maybe controlling access to certain applications if you don't need to execute it, then you don't need to see it. It's going to work the same as it is on physical and virtual desktop environments. So to get more access to or get access to an evaluation or any more details around FSLogix app masking and Java version control, you can go to insentra.com.au/ Aaron Parker, FSLogix, and we can arrange an evaluation and assist you in setting up that environment. So before I go to questions, because I think I have one here, we are next month, we're going to be talking about Cloud Cache. So we've got a guest, Gabe Knuth from FSLogix, formerly of brianmann.com. He'll be in the studio with me to talk about FSLogix Cloud Cache, which is a very, very interesting feature coming up to support their Profile Container and Office 365 container products to deliver these in on-prem public cloud environments using cloud-native storage with replication between multiple environments, so I can improve failover times, I can improve performance, and simplify disaster recovery. So I think I've just got one question here on app masking and Citrix app layering, which I did talk about previously. So just recap there. You know, how does app masking compare to Citrix app layering? And I think it's fair to say that in many instances, these two products are complementary. App layering is a great product to simplify composing and managing applications in virtual desktop environments. If I think about what I can do with app masking, it lends itself to many more scenarios. It can be used to, in conjunction with app masking, to solve licensing challenges, simplifying my layers that I have, or I can use it to replace alternate products such as Microsoft App V or so on, or I can use it standalone to achieve some of the same level of integration that I might do using alternate tools, but potentially, I guess, in a much simpler scenario. So with that, I think that's all the questions we have at the moment. So if there's no other questions, I'll give it a couple of seconds. I just want to thank you for your time attending. And as I say, for more information and our webinar next month, go to insentra.com.au/FSLogix webinars. And thanks very much for attending.